Welcome to our session for SUSECon 2023, SUSE High Availability for SAP, latest and upcoming use cases on-premise and in public cloud. My name is Fabian Herschel. I'm Distinguished Architect in the area of SAP and responsible for SAP HA solutions and also author of the SAP HANA system replication resource.
My name is Lars Pinner. I'm working with Fabian in the SUSE team dedicated to the SAP Linux Lab.
So Lars, what will we speak about?
What will we talk about? We will give you an overview on the current supported SUSE HA scenarios for SAP workloads, for the database, the HANA database, and the SAP NetWeaver application platform. Then we will give you some insights in what you should do with our solutions in real life and what you most likely want to avoid. And we will give you an outlook, what we are planning to release somewhere in the near future as a successor for our proven SAP Hana SR solutions.
Okay, and with that, we will give you an overview on supported HA scenarios.
What are the HA scenarios for the SAP HANA database? I think I will give you this overview, and Fabian then will give you the other one for the application platform.
Yes.
In general, we can distinguish between the HANA scale-up and scale-out scenarios. Scale-up means we have two HANA boxes covering the whole workload on each side. Between these two HANA boxes, we have HANA system application, and from that basic out, we can define several detailed setups. First of all, we have the HANA performance optimized setup, which is the most common one. That means you have two HANA databases connected by HANA system application. Both are up and running, and both are loaded completely into memory. Then we have the so-called HANA cost optimized setup, which means the one HANA is running only with reduced memory footprint. This allows to run a second database on the same host for the cost of longer takeover times. We have for the performance optimized setup multi-tier and multi-target topology supported. That means to these two HANA databases in the cluster, we can connect a third HANA database outside the cluster for disaster recovery purpose or for cloning the data into another system. And we can set up multi-SID clusters. That means one cluster controls several of these HANA performance optimized databases. And we also can put additional SAP central services into the same cluster, but this is more a special case. Coming to the scale-out scenarios, again, we have the performance optimized setup, which means we have the two HANAs. In this case, one HANA database takes more than one node. So we have on both sides a set of several nodes. We can distinguish between HANA scale-out databases with standby nodes, which are currently not in use, but placed there to have some capacity for replacing failing nodes. But we can also run this setup without any standby node. It's basically the same for the cluster. One special case is a so-called ERP system. ERP systems are systems which do heavily write-related transactions in opposite to the analytical workload. And these ERP systems normally are formed out of two huge nodes. So we have on each side two nodes, and this also can be controlled by the SUSE cluster. And as a detail, in this case, in the ERP case, we can also have a second IP address, which is useful for the so-called SAP read-enabled setup. So that's it with the databases, and now we come to the application.
Thank you, Lars. So as discussed about the database, of course, what you also need is an application platform to run your SAP workload. And there are, in general, the more common NetWeaver application platform and the newer S/4HANA application platform, while NetWeaver has its own older technique called ENSA 1. This is the replication of the enqueue logs from one instance to a backup instance. S/4HANA started a bit more modern with ENSA 2, beginning from application platform 1809. And with that, we have also two areas we like to discuss here. So the NetWeaver area, where you have the selection between the older ENSA 1 and the newer ENSA 2 with very new SAP kernels, and the S/4HANA, where you have the ENSA 2 option. So we are supporting for, in both cases, that you could place your application on file systems which are on disks, which are shared between the nodes, or there would be also a file system takeover once the cluster would go to the other side. But we improved that together with a big customer of us and developed the simple mount concept. The simple mount concept works more with mounting all file systems at boot time. So the SAP workload files are placed on a file system which is accessible from both sides, most likely an NFS server. And then you have a very stable situation for the cluster where you don't get an intermix of file system problems, resource problems, and so on. And it's much more easy to be set up. Multisit is also supported, so having more ASCS and ERS instanced pairs in one cluster. The only thing which is really important is that you don't have relations between those pairs. So each pair needs to be able to take over on its own purpose. Then we have the possibility also to add other instances or other workloads which can be controlled by subcontrol into the cluster, and you can simply use the sub-instance resource agent for that. Free-node clusters is the default for S/4HANA because in ENSA 2 you have the situation that the ASCS does not need to exactly take over to the ERS side. So this is a more modern way to synchronize the logs, and with that, this is more like a default or a favorite installation for S/4HANA. For NetWeaver, it's more an option. Could be used if you want to solve the problem of a majority maker in the cluster. And with that, we could proceed on how to succeed with SUSE HA for SAP.
Yeah, thank you, Fabian. So we have learned about supported and documented setups. And once you have set up your cluster, you most likely will run it for production. And during the last decade, we found some things are useful and some things are not that useful. So we will give you an overview on what you should do and what you most likely should not do. We will start with the things you should not do, and then finally we will concentrate on the good things you should not do. I will start with what you should not do, and one of the basic points is, if you are familiar with whatsoever cluster, don't try to use your proven concepts from whatsoever cluster with a Linux HA cluster, because some things are special to a particular cluster implementation and might not work with Linux cluster. Another thing is you should not try to solve money while installing HA. High availability always means redundancy, and redundancy always means extra cost. And the benefit of this extra cost is that you will have a higher availability, and at the end, this higher availability, this lesser outage will save you money. You will not save money by saving on the infrastructure side. This is a wrong approach. One obvious thing is we have documented a lot, and you should not ignore the existing documentation. You should not ignore the manual pages we ship with the product. There's lots of information in there. You can do things that are not in the menu, not in the setup guides. This is normally covered in blogs or manual pages. It's always a good idea to know where to find the information. Timings is an important point. You have to make a decision, a trade-off between takeover time and on the one hand, on the other hand, the tolerance the cluster has against short outages. The faster the takeover time is, the lower is the tolerance against short outages. So this has to be balanced for your situation in your environment. You should never try to handling a resource which is under control of the cluster manually, except you have told the cluster before that this resource now is not to be controlled by the cluster. This is a very basic thing. Another thing you should not do manually is typing a lot of commands to try to force the cluster doing something. If you have issued a command to the cluster will perform it, but it takes time to find out the current state of the resources and to make a plan how to fulfill your wishes. And so you always should take in mind it takes its time to perform the commands you have issued. Normally you should wait until the whole cluster is idle and the resources are fine again, and then you can think about what to do next. One thing that comes back to the coast, you should always have a test cluster for every production workload. Something that is kind of similar to the production load should be held in a parallel system to be able to perform tests, for example, for software updates, or if you do a maintenance procedure which is not that often needed, so you can do a dry run before you try it on your live system. And this again means that this parallel system, which costs a little, will avoid downtime on the production system, which might lead to higher cost than this tiny test system. And you should never go into production without having tested everything you want the cluster to do in production. That means you should test failure scenarios and you should maintenance procedures as well test. And with that, I come back to the perspective what you should do, and Fabian will explain now what you really should do.
Yes, and thank you, Lars, for giving all these insights on pitfalls. So what you should do is, first of all, to ensure that there is a resilient cluster communication. So if the cluster communication breaks down in every short period, then the cluster always needs to calculate what to do now. So it's communication between cluster nodes must be also available and in a good manner. We recommend to have SBD as a STONIF device, and if you are using SBD, we are heavily recommend to have free SBD devices. There's a difference between having only one SBD device, having two SBD devices, and having three of them. And you can imagine that having only one could be a bad way because you don't have high availability on SBD devices. And only if you have three SBD devices, you have something like a maturity maker also between these devices. So you have always a correct way to know which cluster partition has enough SBD devices to declare itself as the better partition. Then look at your infrastructure. In general, in our setup guides, we can give you a first insight how to start with, but we don't know your infrastructure. We don't know on which cloud you are running. We don't know if you have long latencies between your systems or between your systems and the SPD devices. So you need to tune this to adapt the cluster to match in best into your infrastructure. One cluster principle between patients when you are doing things with the cluster is to keep it simple. And this means keep this cluster information base simple by using a naming schema. Don't add too much to the cluster, which is just being wired and just you think it's a good idea. Follow our best practices and don't add too much functionality to your cluster and then wondering why it is being handling things different than we defined it in our best practice guides. So if you set up, go step by step, check each of these sections and steps in your setup that it is working properly. Also be careful that your workload itself could at least work as you have planned, because if you, for example, have a system replication not running and not working, or you have an ASCS ERS instances, but they do not syncing, then the cluster couldn't repair that. So if you couldn't do it manually, then later also the cluster will not be able to repair that, because it could automate detection of failures, automate takeovers, but it could not repair broken infrastructure, could not repair broken software if you have mail configured it. So then you need to have a team which is looking at your infrastructure, Linux and SAP. So if you have different teams for that, please align them. Have a methodology how they communicate. For example, that if the infrastructure team would take down the network because they have a change request for that, but does not inform the Linux cluster guys and the SAP basis team, then we will not be successful in your company. Test your cluster in parallel to production means that if you want to do things with a cluster, like preparing for maintenance and so on, it's a good and very good practice to have a test cluster for that. First working on the test cluster and then doing it after you are sure your procedure is correct in the production. And define and perform tests for all failures you want to address, that you are sure that at the point of setup your cluster is working. Because if it is not working at the beginning, it will also most likely fail if something happens in your production which should be addressed by the cluster. So with that, you have a good, I think, insight about good practices we want to recommend you to follow. So now we speak about 10 years of SAP HANA SR and what comes next.
Yeah, 10 years SAP HANA SR. Our solution started right short time after SAP announced the HANA database and the concept of system application. At that point in time, some decisions have been taken, what our solution is expected to do, what we can rely on for our solution. Unfortunately, over the time, some of these paradigms have been changed. So, for example, in the beginning, system application was pulled from the cluster by asking the HANA about the status, and there was no other way available. Later on, we got the option to be informed from the HANA asynchronously on the status of the system application, and this is now reflected in the two options, in the two attributes, sync state and SR hook. This is one point where you can see the historical evolution Also, our resource agents have been designed depending on, for example, the HTTP settings tool, which comes from SAP. In the beginning, this tool was very fast. Over time, it slowed down, and now it begins to become kind of a problem, this runtimes of this external tool. Also, you have maybe also seen that the two resource agents, SAP HANA and SAP HANA Topology, report the status of the HANA resource in slightly offset way, because they are running independently. They have certain runtimes, and while the overall situation is tracked by the SAP HANA Topology, the current state of the resource is tracked by the SAP HANA, and sometimes in phases where the HANA is changing dramatically, this information might look confusing to a human. Fortunately, the cluster can handle this. Infrastructure in general are not very well covered because this is something we have decided to abstract from by relying only on HANA information for our cluster actions and decisions. And it turned out that for some situations, particularly file systems and other infrastructure problems, HANA does not take care of. It's another month's problem. This means for our cluster, we cannot really rely on what HANA is telling us about this. And this is definitely an area where we should look into to improve things. And since HANA in the beginning started with scale up only, there was no plan for scale out in the very first phase, at least not commonly known or known to us. So later on we started with scale out, and we found out that some attributes are missing or not optimal for scale out. So we decided to go with different solutions or different code for scale up and scale out. And this leads to the situation that we now have two code bases and two different sets of cluster attributes for scale up and scale out, which is something we might want to improve. Yeah, and now, Fabian, can you tell us how we will address this?
Yeah, thank you, Lars. So what comes next? The next step will be SAP HANA SR NG for next generation or advanced next generation interface. So one thing we want to address with that is getting a common package for scale up and scale out, containing all needed resource agents for all scenarios we have so far, including the hook scripts, so that you can directly integrate them. Having the tools that you can monitor the cluster and have a look at it, and also the manual pages which give you direct information about how to use commands and how to do maintenance procedures. There will be two common resource agents called SAP HANA Controller and SAP HANA Topology, and they will be using common SIP attributes for scale up and scale out. And this also will limit the backward compatibility of SAP HANA NG. As you can imagine, it's not that easy to get completely changing the attribute tree and to be backward compatible. For first, SAP HANA NG will be a technical preview and will be available with SLES for SAP 15 in SP5. Technical preview means that you shouldn't use it for production, and you will get support on a way of best effort. So we want to get your feedback and want to help you because now we have a chance to bring SAP HANA NG to a next step, and hearing your feedback will help us that you give us the direction you as customer want us to go through. And now we have a chance to move things forward. It will be a refactored package, modularized in the code base. So also the two resource agents, SAP HANA Control and SAP HANA Topology, have a lot of functions internally, which were in the past being in a parallel code tree, and now using common functions. So that fixing a problem at one place fixes it also at the other place, make it maintenance easier. And for you as customers, if you fix a problem in scale up, it's also fixed for scale out. The resource agents will be a bit more decoupled and getting more interdependency in transactional phases. for example, limiting runtime impacts of external interfaces. So if SAP HANA resource, if the SAP HANA database is being answered a bit slower. This will also, we are following a new upstream convention coming from the pacemaker community. They change right now a bit more from the multi-state resource we had before to a clone resource with a meta attribute promotable. So in a glance, it is the same mechanism of promoting, demoting, starting and stopping, and the same mechanism of having a primary and a secondary. Yeah, so it will be quite similar, but a bit different to what you have seen so far. And with this is also what we want to show you in this SAP HANA SR Angie demo. So around about between 8 and 10 minutes, where you first, in the first step, integrate into an already installed HANA with a prepared cluster, and we want now to integrate these two parts. And we have prepared files for that, so you can easily see, if you follow our concept, how easy it is to integrate the running HANA into the cluster without being restarting any of the primary or secondary sites. In the second step, we will show how a primary failure leads into a takeover triggered by the cluster and a re-register of a former primary. And with that, we jump right now into the demo. So welcome in our lab. We have here a TMOC session where we have here a CRM1 output, 2 nodes, only simple resources like SPD and the IP address already configured, no HANA resources. You see with the Show HANA Attributes tool that we have no attributes currently in the cluster. So it's completely plain. We have a client connected to a cluster IP address, which is in status OK, and a local client on the current primary, which is in status OK. And now we are adding resources to the cluster. We have a running cluster, we have a running HANA, and we just add what the topology configuration is. The cluster adds the resource to the configuration, starts this, and as a result, you can see the first attributes being added here in SAP HANA SR show attributes. Now we are calling the same mechanism for SAP HANA controller, where we add a resource in maintenance status. And you see that now this is an unmanaged resource being added, but by probing, already attributes are added. So we are currently see about the landscape of our system replication here in SAP HANA SR show attributes. You see the primary, the system replication roles, the scores, and the site names. Now we take the resource out of maintenance, we end the maintenance, and then the cluster takes over the control of the SAP HANA. You can see that it is now monitored and resulting in a master and a slave status, so promoted and demoted. In the attributes, you see the LPTs are set correctly. The landscape status is both 4, which means OK and running. The master name servers are detected correctly. We have the hook attribute about the system replication, the hook mode, and the podding result. And the system replication role, the primary and the secondary site. In the host table, we see, of course, the host name, the clone state. Promoted is typically the primary. And the roles, including the active roles, the scores inside of the cluster, and the reference to the site names. In our client, we can still see that everything is set up, while sometimes the application does an internal reset. You can see it is still working with the cluster IP address as well with the local IP address, because it is directly also running on the primary side. And now we want to see what happens when we break the primary using our semi-automated test tool we are using internally for getting SAP HANA SR a very good package and delivery. So it's now detecting that it finds a valid situation, breaks the primary, and we can see in the situation of the client to the cluster IP address as well local. We have this problem detected already. The cluster sees that something changed. The LSS is already on 1. The secondary already does a takeover. And we can see that the scores have been adjusted. So the secretary can do that or is advised to do that. We can see in the roles, you see that the active roles of a former primary are missing. And the LPT values have already been adjusted to the current situation. So we have a down and crashed primary and a running or intake over primary now on the other side. Now it takes some time till the takeover itself is being processed, HANA internally. And later on we will see that the cluster, depending on our configuration, will also do a takeover, a register. Now it is here marked as a takeover. So you can see in these attributes what the current transition status of a resource is. In our case, it takes a bit till it has been processed, depending on the load. You see here the client already is connected on the cluster IP address, while the local client on the former primary, of course, still have errors. And we see that new values are now again filled in. So this takeover from application side is successfully. So we see now it is the takeover has been processed and is through. And now we are waiting the register, which is happening now. So now the old primary gets the new secondary. After the register is finished and is being marked out here, the cluster will process the HANA start. We see the takeover hook is on SRAC, while the SR poll attribute shows SFail, which is showing the result of the polling. And we are now waiting a bit that the client comes up, and then these attributes will change from within a short time. So currently we see that the register is through. The attribute changes to swait, so we are waiting for the next hook event. You see that the landscape status is changing to 2, which means it's a starting or changing HANA. So this HANA is still working on getting the completely up for the system replication target. We can see that the roles are still do not show active roles, so this is still showing that there's something in progress. And this might a bit take some time till this attribute active role here marked will change that it looks like for the started primary. So this happened right in time. So we are now waiting for getting the SR hook event. We are waiting for getting the landscape status. So focus first on the SR hook event, changing from swait to SOK. And let's see, it takes some time till the replication is working. And the HANA still is starting maybe the index server within behind and doing other things. So it could be that different challenge needs to be addressed. Now it's going to SOK, you have seen. The landscape status is going to 4. And also the polling attribute will be switched during the next poll, which is the next monitor interval. yeah, this also has been fulfilled. Last not least, the scores has been adjusted correctly for the former site and so on. Also, our test tool has said this is a successfully test, so all attributes has changed in the way we are looking for. The cluster client is still working, while the former primary, of course, still doesn't, still is in fail. So this was a successfully test, and with that, goodbye. So we are back from the demo. I hope you have enjoyed it, and with that we come to the summary.
Yeah, thank you, Fabian. First of all, I would like to summarize for you where you get the details we have mentioned along with our slides. First of all, we ship manual pages with our packages. So with the command apropos SAP, you will see lots of them. And starting from there, you will find even more manual pages with all the details you want to know about, or even not. And then, of course, we have our web pages. We have the port documentation. We have the product documentation. And we have the blog series, mostly written by Fabian, the blogs. We have also an online available SAP training course about our HA solution. And with that, we can go to the final summary of our session, what you should take with you, what you maybe want to take with you. First of all, we have more than a dozen supported HA scenarios for the SAP workloads, the database, and the application platform. If you find something that is not covered by our solution, please contact us. Maybe we can help you. We will see. Together with our setups, we document procedures, how you should work with a cluster, how you should work with a workload. This is also documented at the website and with the manual pages. If you're unsure, you may want to first look into the documentation before you try something out on your own. And it definitely helps to follow our best practices. These best practices have been evolved over the last 12 years or so, so there's a lot of experience already that we have done, that our customers have done, and there's no need to stumble into every pitfall on your own. And from what we have learned during the last 10 years, we now are starting to develop the next solution, the SAP Hana SR Advanced Next Generation Interface, which is aimed to become the solution for the next 10 years or so. And of course, if something is unclear, just call us or call our partners. We can offer you a wide range of training and consulting services. And as well, of course, our support, which is the basic of our subscription. That was it for now. Have a lot of fun.
Thank you for watching.